Calc BC, the station activity, we're looking at problem 11. And again, your goal is to always start by saying, do I see an obvious antiderivative? There's a danger sometimes kids might want to say, hey, how about we distribute that x inside the parentheses? The problem is you'd break the order of operations. This x squared plus 1, if you didn't have this power, that's what you should do. But that power of 3/2 is really complicating matters. So I can't just distribute an x inside. Instead, I'm seeing a composition. I'm seeing a function inside of a function. So let's try a u substitution. We could let du just be 2x dx. If I solve for dx, I'll get du over 2x. The wonderful thing about this problem is you don't have boundaries. I have this x out in front. I'm going to keep it out in front. I now have u to the 3/2, but my dx, I'm going to write as du all over 2x. And I hope you can see very quickly that this x and this x are going to be gone. They cancel. So I've got a 1 over 2, so I'm going to factor out a 1/2. And here's your u to the 3/2. Well, what do? Well, we're going to use our antiderivative. I'm going to bump that up by one step. I'm going to add 2 over 2, and I'd get u to the 5/2. Dividing by 5/2 is the same thing as multiplying by its reciprocal. So without too much work, kids are going to see that you have 1/5 u to the 5/2. Notice how without these bounds we need that arbitrary constant. However, our problem was in terms of x. I'm going to have to resubstitute in now. I'm going to say here's my 1/5. Let's erase that, having some problems with the pen. So we'll say here's your 1/5. Wow, let's try writing to the right of this. I don't know if maybe that would help. Say 1/5 and then, let's see. Okay, just tried to reset a couple things here. This would be 1/5, but instead of writing u, let's replace what we were substituting in. That u is x squared plus 1. We're raising it up to the 5/2 plus a constant. So that's really where we're going.